The purpose of this class is not necessarily to, show you. The tool is fairly simple once you're familiar with it, but going through it the first time can be a little bit tedious. So all I really want is for you guys to get familiar with maybe the idea of, hey, it's time for a silencer, or hey, maybe I'm okay doing a little bit of line ductor or something along those lines. So the screen that you're looking at is the all-in-one selection software. It has a bunch of tools in it. Price makes it. It's, considering that it's free, it's a pretty powerful acoustic predictive software. So we're going to go through a handful of different examples. And there's some engineers on this call and there's some contractors, but one of the things that happens a lot is you got a rooftop unit, you got an exhaust fan, you got a makeup air unit, you go, all right, I'm worried about it being a little bit too loud. I'm going to leave myself 5 feet, 7 feet, 3 feet for a silencer. And I think I've got maybe 2/10 of an inch that I can afford to work with. How do I pick a silencer? I don't really know what I'm looking for. So if you're following along, in the selection tool in the wizard, you can either do terminal boxes or you can do silencers by performance. This is kind of a cool thing. And so obviously you can put a tag in here. I just wanted to go through all the little pieces and parts before we get into acoustic predictive, and then we'll do a little simple selection, then we'll get into looking more at sound power levels. So we're going to pick a silencer. Most of the silencers you're going to pick are absorptive dissipative, which means that there's fiberglass covered by a perforated screen. So that works great. It's got the best standard performance. In healthcare, particularly on the supply and the return side, it may not be permissible to have the fiberglass exposed to the airstream. In those cases, we will line the media with a polymer film. Some people call it Tedlar and some people call it Mylar. Price calls it polymer. And that does have a negative impact on the insertion losses for the unit. There's also, for labs, there's very rarely will we use a packless silencer, which is just basically allowing the metal to vibrate and knock out the sound that way. Very limited insertion losses with that, but it's available. Okay, we can make a silencer that's rectangular. We can make it an elbow shape. The elbow shape can be oriented more for a down discharge rooftop unit, or in an elbow configuration in the duct. And then we can also make the casing bigger. So if you're looking at this drawing right here, in order to increase the insertion losses for the silencer, we can keep the duct connection sizes the same, but the silencer geometry will get a little bit bigger to allow a little bit more insertion loss, particularly in the lower bands. So here is the desired insertion losses, starting with 63 hertz octave band, going all the way up to the 8,000 hertz. So I'm just going to hop over here before we do the first selection. In the event, like Ken Greshel does some industrial applications, so does Tweet Garrett, you may get into situations where the duct velocity is higher than 2,000 feet per minute. The software will let you know to think about that. We have something called fiberglass cloth or fiberglass cloth bagged. And what it is a real fine sheet of fiberglass that goes over the media. So it's still fiberglass. There's no reduction in insertion loss, but it's really built for industrial silencers. We're not going to be using that, but it doesn't change the performance. One of the little boo-boos talking about liners is an engineer, I've seen it many times, where they will select the performance data off an absorptive silencer, and then they'll add the film lining like it's an accessory. It's not the performance isn't the same, so it's something to keep an eye on. If you're going to pick a film line silencer, use the film line silencer data. Okay, back to this side. There is a natural fiber media instead of fiberglass. I wouldn't use it. It has some sort of made out of the same material that blue jeans are made out of. It is not as durable for the long term. If you want to protect the media, use fiberglass cloth or use the polymer liner. I wouldn't bother with the natural fiber. You can make it heavier to match your duct construction. Sometimes in more intricate systems, we will have to use heavier gauge casings for breakout noise. This is not the kind of training class we're going to talk about that. That'd be the kind of thing, send it in, and we will work with Price to do the acoustic predictive. You can change the gauge of the material. You can change the ends to have flanges, that kind of basic sheet metal stuff. So let's say we were going to do, you had a makeup air unit or a dedicated outside air unit on the roof. It was 20,000 CFM, and you were coming across, let's see, let's say it was 40 by 24. We're going to allow it to pick a maximum length silencer. We can let it pick shorter, and we're going to have 20,000 CFM, and we're going to allow a pressure drop of 0.2. A lot of times when I started working with, when I was working with other silencer companies, I kind of thought they all needed to be 1/4 of an inch, but is totally within the realm of possibility to design silencers at 0.1, 0.05 even, and still get a lot of insertion loss. So don't assume just because you need to put in a silencer that you need to have a lot of pressure drop associated with it. So this is one other thing to pay attention to. If you're on the discharge side of the unit, it's forward supply. If you're on the return side, it's or exhaust, it's going to be reverse. It will change the performance of the silencer slightly. There is an inlet and an outlet on a silencer, so you don't want to just flip it around the field. So let's say we're concerned about sound. All we have to do is pop in an insertion loss in one of the bands and do a search. It will take all this criteria in. It's got a pretty high velocity for this application that I'm just making up. Notice the pop-up here is saying we should consider using fiberglass cloth. And now it's going through all sorts of different iterations of different module sizes to determine which one's the best. So this is a wild guess. So because we picked a pretty low pressure drop and a pretty high velocity, what it's done here is picked an extended casing silencer. That's what these RHX middles or RHX models are. And you'll notice we're getting pretty good insertion losses, and we're getting sort of what I would call an expensive silencer for the size. So it's done a lot of selections for us. It's narrowed down the field. It's giving us our performance, and it's built the silencer around that pressure drop. So I'm just going to edit this just a little bit and say if this was 10,000 CFM instead of 20,000 CFM, what kind of results we would get. So we still want 20. We still want our pressure drop the same, just to demonstrate sort of how flexible the software is. Oh, you know what, and it could have been, I take that back. I had the extended casing selected. Uh-oh, that's not good. Let's redo this and see how we do. It's going through a few hundred different iterations for all those different sizes. And we'll see what we get. Notice that detail for media protection's gone. Now we're into, and I just happen to know the models. These are the standard silencer models. You'll notice our insertion losses, even though the pressure drops changed a little bit, our insertion loss is still closing in on the target, and the silencer price has gone in half because we've gone to a standard configuration silencer instead of a casing. but we've also cut the silencer length down pretty significantly. So we can get a lot of data crunched together to pick a silencer. One other thing before I leave this page, and I'm leaving the list prices up here on purpose. Our multiplier plus a markup, call it like 8. So these silencers are somewhere between $600, $700. Silencers are cheap. You know, it's not much more expensive to put sheet metal in than it is to buy a silencer and put it in. And the insertion loss is pretty powerful. So there isn't a whole lot of reason not to consider silencers because of the cost. Now, if you use Vibro Acoustics, for example, they specify very expensive silencers on a regular basis. Those do get to be costly, but you can see what you can get done with just a few bucks on most systems. Okay, so enough of this is kind of the simple stuff, just to let's see what it looks like. And we're gonna move now into the acoustic predictive. Before I jump out on this particular page, any questions anybody would like to throw out there? And that's fine if there aren't. I have a tendency to go a little fast, so.
Hey, Tom, you have to enter a target and insertion loss, right? You can't leave all zeros in there?
It takes a long time to run the program when you don't put any data in because it doesn't really know what you're looking for. So that's true. That's true. And you know, also, this is all-in-one is kind of a big file for engineering. So just one of those things to think about as you're uploading and downloading programs. Okay, so I'm going to close this. I'm going to open up the acoustic analysis. You can kind of see this tab over here. And in order to make sure I don't bomb this presentation, I put the examples in, and I want to kind of walk through those with you pretty slowly. So this first one, you know, with COVID going on, we're going to see some more applications for isolation rooms. We're going to have low CFM, high static fans as we're pulling through HEPA filters, that kind of thing. So this fan, I just picked it out of Lauren Cook software. So this is a fan you might put on a isolation room if you're trying to blow the air up 10 feet over the roof line, for example. So we're going to gather up the data on this particular fan, and you know, every fan manufacturer should have sound data. I think they all do, unless it's sometimes industrial fans don't. So this is our inlet fan data. And it is also important to know whether you've got discharge or inlet data. This is our inlet data, and here's our parameters. So octave band 1 through 8 in decibels. So let's jump back to the program, and you can see up here that I've added exhaust fan 1. I've put the airflow in here, and I've selected the return path. Even though it's not return, exhaust is kind of the same way. And here's the data that we've plugged in. So we're going to take a look for a few minutes at this NC curve. And if you're not familiar with the NC curve, don't feel bad. I was in the industry for like 20 years before I started paying attention to the NC curve. Some of you can chuckle at my expense, but it was, you see NC levels or you see octave band levels, but if you're not using acoustic predictive, you know, they don't mean a lot to you until you see like numbers you're not used to seeing. So I'm going to blow this up just a little bit. And here's the takeaway. So we've plotted this red line. These are the sound power levels of the exhaust fan, right? And we've decided that since this is a patient room, the patient room is going to be NC 30. So from here, you're taking a look and you're going, all right, at 250 hertz octave band, the octave band that's closest to, or the most prevalent for human hearing. What kind of a gap do we have? Well, we're here up at 86, and we got to get down to 43. So an over a 40 decibel drop. Now, the question you can ask yourself at the beginning is some liner going to take care of this? Is a few elbows going to take care of this? or do we need to really start thinking about a silencer? At 20 dB, probably going to be in good shape with a few turns of duct. And you'll see as we go through the program how each of those things is going to affect your run. On the other hand, if you have a straight shot, no flex, right up to the fan, you better be thinking about a silencer pretty quickly. Otherwise, you're going to put that fan in, turn it on, and the owner's not going to be very happy with you. So this is a good chart always to start off with, to see, you know, kind of our range of how far we got to go. It's also important to note that the NC value, or I'm sorry, the octave band levels at different NCs are different. So it's harder to come by losses at 63 hertz. You don't have to go as far to attenuate 63 hertz, for example. And 63 hertz would be like the rumble of a fan, the really low, oh, kind of sound that you get off of a fan. Okay, so now I need you to put on your imaginations and kind of take a look at how we're running this path. So we've got the exhaust fan. We're going to drop through the curb 8 feet. Okay, now we're going to describe what that path looks like. So we've got, how you do it is you just add elements. So you're adding a straight duct, you're adding an elbow, you're adding a T, you're adding a silencer. We'll talk about some of this stuff in a little bit. And I don't want to do that so it disappears. So healthcare, we're probably not going to be putting fiberglass. It may be okay to put fiberglass in the exhaust path, maybe not. It's got a HEPA filter. You don't want your HEPA filled up with fiberglass. So we're going to line the duct. The liner can be 2-inch or 1-inch. Now, I want you guys to look at this straight duct as I'm making changes. If I change from 2-inch to 1-inch, the duct doesn't care. So what in this case, but it's good to know what things do affect your path and what things don't affect your path. So the exterior liner, as you might imagine, doesn't do a whole lot for acoustic performance. The fact that it is lined compared to no liner, small, not a whole lot. But if you are going to line it, take the credit for it. Okay, now we're going to put in an elbow, an unlined radiused elbow on the exhaust side. It's rectangular. Of course, you know, you could make it lined, but if you're not lining the duct, you're probably not lining the elbow. And it could be a square elbow, it could be radiused, whatever. It keeps the duct size for you, which is nice. It's keeping your airflow too. The bend direction matters. Let's just take a look at this. So 0, 1, 2, 3, 3, 3. If we change the bend on the elbow, it makes a small difference. I mean, the more turbulent the airflow is, the more insertion loss there is. So we've come down through the curb. We've turned into the horizontal. We're running a straight duct. And now let's say that there were 2 rooms and the 2 rooms were 750 CFM apiece. So we're going to build a T. And the T is going to have, this is our T, 90-degree T. And you know, for the contractors, it's going to be super easy. You guys are doing duct layouts all the time. And you know branch A and branch B and all this kind of stuff. But here's our main 18 by 12, 1500 CFM. Then we're going to branch off with 12 by 12 and half the airflow. And that gives us, it's a good, kind of a good rule of thumb that there's a 3 dB loss every time you make a turn. It's not always a hard and fast rule, but if you're ballparking your acoustic predictive, 3 decibels is a good way to go. And then so we're going to have a sidewall grill going into the room. This is this end reflection thing is kind of a newer thing than the acoustic predictive. It came out of AHRI 885 for testing, but when you go from a small duct into a big space, sometimes well, not sometimes, they've done testing where that has an influence on the room. So now we're going to talk about what the room is. Because the room, as you might imagine, if the room is covered in shag carpeting or if it's all tiled and hard walls, the room's going to perform differently too. So we're going to spend a little time here. So we got an indoor receiver. So pretend it's a microphone that's listening for the sound coming from the fan. How big is the room matters. So isolation room, I think this is a good rule of thumb. How far in the room are we away from the receiver? So I said, 10 feet away from the grill. If you change this dimension, that distance, the receiver value will change. So you don't want to over or underestimate it. There's one sound source. And then there's some particular details in here about the method in the room and all this kind of stuff. If there are questions, you can hit this information box. And it gives you a lot more detail about, probably more detail than anybody would ever want if they weren't an acoustician, about how this information was arrived at. But the point is that it's not made up. It's all documented, supported from ASHRAE and other acoustic sources. So it's more along the lines of, if you wanted to know in general what the receiver was, this is it. And of course, we're going to select by NC. You can't do an acoustic predictive without knowing where you're trying to get to. And then here's a little guideline for you for what kind of NC level you should expect to shoot for. It may change job to job, but we're looking at a patient room and our desired NC is 30. So we can see here that we're not quite getting the job done. Actually, we're pretty far off. So if we blow up this again, we seem to be okay. So we started off way up here, and now we've put in some ductwork, and we're okay in the 63 hertz octave band just by nature of having turns and end reflection. But we've kind of got a ways to go, in particular at 500 and 1000 hertz. So it looks like we still have 30 to go. Is 30 a lot? It is, as far as decibels go. So all I did up here, you can see there's this copy, duplicate, cut, and paste. I copied the exhaust fan analysis and just pasted it over here. So this is a nice time saver. All your data is the same, your duct path is the same, but what I did was I took this straight duct and I disabled it by right-clicking it, and I hit disable instead of enable. If I wanted to re-enable it, I could. Or let's say my silencer didn't come out at 10 feet, it came out at 5 feet. I could put a piece of duct back in there, but you can also know that we're not getting a lot of attenuation out of a straight piece of duct, so I wouldn't even bother. So what I did was took the straight duct out, I disabled it, and then I created a place for a silencer. So it carried my width, carried my height, and I'm allowing it to match that length of 10 feet, and knowing that I have a pretty long way to go. So let's say, so this has already been selected. You can see our duct size, our duct velocity, our maximum pressure drop, and I was able to get a silencer that's at 0.23. If we were to change our parameters to 35, or let's say it was 40, not 70, Tom, 40, and I wanted to keep everything else the same, and we've got, what do we get? We got an 18 by 12 by 10 foot long silencer. Let's see what that might look like. And I'm just playing around. Notice it tells you that the octave band you need to satisfy is 500 hertz. And that's where we got up into a lot of insertion loss. So with the original silencer, we got to NC 43, which does not satisfy our requirements in the first place. In changing these around and opening the selection up to NC 40, we still can't get it done with the 10-foot straight silencer. So I'm not going to replace that silencer. Yes. So what I did was copied it again, and now I'm taking a look at an elbow silencer. So again, the path is identical, but in this case, I disabled the elbow, I re-enabled the straight duct, and I did another selection for a silencer. So here's a vertical silencer. We're taking our drop, turning it 90 degrees, and we're still trying to get to 30 NC. Now with this silencer, note how grand the insertion losses are. We're able to get to an NC 29. So the silencer is quite a bit more expensive, but we were able to solve the equation and get to under NC 30. And this would be a pretty typical application. I often notice that these aren't silenced, and then we get out to the field and they go, yeah, so, something's kind of wrong with your fan. Nothing's really wrong with the fan. It's we didn't pay attention to the analysis. Now, one thing that does happen is after our drop, we may want to change the leg lengths. So instead of having a perfectly, it's hard to show on your camera here, perfectly even, we may want to make one leg longer than the other. That's a lousy demonstration. So if it was like that, we might want to make this shorter and this taller, or vice versa, and make it. It doesn't affect the acoustic properties in a big way, but it does certainly make it a lot easier for the contractor to prefab his ductwork and get it all laid out in the field so it fits, because you don't want the bottom of the duct dropping below the ceiling. So that's what we did. We were able to maintain the pressure drop. We're able to get all of our insertion bands met. And when we get to our model, it shows us exactly how we did. So we were pretty good on 63. We had to work to get our 125th band, and in particular the 4,000 hertz octave band, the higher frequency, to get every one of those below NC 40. Now, for you consulting engineers who review shop drawings for silencer manufacturers, let's say that you laid it out with price, but then VAW came in and their insertion loss was off by 1 or 2 in the 500 hertz octave band. Should they be rejected? No, they don't need to be, as long as you know what the path is. The flip side of that is if you change the fan, you may have more or less octave band requirements to satisfy the equation. So if anything, you may need a little bit more silencer to accommodate for this manufacturer's sound performance and that manufacturer's sound performance. I know in this model, York is really loud, and this model Train's really good, and vice versa. And then you get into custom stuff, it gets tricky. So as you're doing acoustic predictive, you may want to leave yourself a couple extra dB if you can, and cough up some pressure drop to accommodate it. And sometimes we just redo all the selections based on the equipment that's there too. So with that, so far with the sort of the one-off model, any questions, you can throw it in the chat box. Dave, Tamara, how's the pace? Are we going at a good pace here? So far, so good?
So far, so good.
All right, sounds good. All right, now we're going to take a look at a different one. So I asked, Airflow does sell rooftop units. We sell an off-branded York product called Fraser Johnson. So I asked Refrigeration Ron to give me a submittal for a rooftop unit. And this is kind of a typical thing. Here's the submittal. And I'm going through and I'm like, oh yeah, okay, it's a 25-ton unit, it's a VFD unit, it's got this, it's got that, blah, blah, blah. There's a picture of it. Here's here's how to order it. Here's the duct connections. There's the components, and there's the venting, and a couple other. And I'm like, well, wait a minute, where's the sound data? This is not particularly helpful. I got to give it to Train. Train includes their acoustic media with every submittal, so that's kind of nice. So that wasn't available, but oh, I just lost it here. Well, come on now. see what I want. Oh, it's because I got it on the wrong screen. Sorry, everybody. Sometimes it's this sound data is in the I01M manual. Sometimes it's, so anyways, we were able to dig up this 25-ton unit, 10,000 CFM. No, we've got a discharge performance. We got to select that and just eyeball this to yourself and go, all right, 95, 88, 85, 83. Silencer, yes. Silencer, no. You want to roll the dice on it, or you think it's worth looking at? Every time I see high 80s and 90s, I'm thinking at least a look for silencers is probably a good idea. If the first band was 85 and we're dropping down from there, you might be able to get away with line duct, but it's always a good idea to look. Once we're in the 70s, there's a couple of turns, you may be safe. So just kind of a high level as we're looking at it. Now we're going to jump back into the program. We're going to look at our analysis. This is a little bit longer run and see how we do. So going to our receiver, this is a 25-ton rooftop unit. So we're serving a larger office. So we're going to say office, it says 30, we're going to target 35. Our room is a lot a bit bigger. We're going to still be 10 feet from the diffuser. This is our sort of standard room level or standard room receiver. And one thing I'm going to do differently in this one is I'm going to have some flexible duct in it. If you take a look at the duct, there's a lot of insertion loss with flex duct. And this is probably not a very representative sample of flex duct, maybe really cheap flex, but you do get a fair amount of insertion loss with 5 feet of flex duct. Okay, so we're going to go, it's a rooftop unit supply. There were dimensions on that unit. I just guessed at a duct size of 60 by 30. We're going to drop down. It's exterior lined. So we got 2, 2, 1, 1, 1, 1, 1. Hey, maybe I feel like, let's see what it does if we're going to line it. 2-inch liner. You'll notice we got some insertion loss in the middle bands. We didn't get a whole lot of loss in the first 2 bands. So what's that telling us? The tighter waves, the higher octave bands, the waves do get kind of attenuated with fiberglass, but it may not do enough. So I changed that. Originally we were at like NC 43 and now we're at NC 37. So it solves some problems, it doesn't solve all of them. So we're going to go back to exterior line straight, change our parameters. So we got to an NC 37 just by lining the duct. One other thing to consider is if you're doing healthcare and you can't use flex duct, that is where a lot of the problems come in on the healthcare applications. All right, so drop down from the unit, elbow over, we're running a straight section of duct. We're going to start doing our branch duct work because we have to cover a wide space. We're assuming that ductwork is above the ceiling. We're going to have another straight. We're going to have another T. And you notice how much we're giving up every time we get to a junction. Then we're going to branch off from our junction from rectangular 30 by 12, 2500 to a 400 CFM round 12-inch diffuser. We're going to put the duct in, and we're going to have the receiver. Now we don't have that end reflection because it's a ceiling diffuser. It's a kind of a different animal. So NC 43, and we have been targeting NC 35. So copy the path, disable the straight duct, and now we're going to take a look at a price silencer. And here's all we did. We took the performance information. Now, RL36, that's a standard casing silencer. It's only 3 feet long. But we went from, what was it, 43 to, oh, we have 35, yeah. unsilenced 44, we got our NC down to 35. We've satisfied it with at 1/10 of an inch pressure drop. Pretty low velocity. If we sped it up, we might be a little bit higher. And the list price, you know, this is what is that? A $700-800 silencer to solve this. We've attenuated the entire system. So nothing special, nothing unusual, super cheap silencer for a pretty big system, and away we go. Now, that's the supply. Often the return path is a little bit worse for rooftop units because they tend to have fewer turns, because we can get a return from, we will always get a return from probably the closest avenue in the space to limit the sheet metal. So again, we've got a different dimension on the duct. Instead of 60 by 30 to match the unit dimensions, you guys can look up what those unit, I think it was like 70 by 20. We have a different straight duct. We have a different elbow. We have a different straight duct. We have an end reflection. And wait a minute, we're targeting NC 35, where we're even worse off than on the supply side because of the straight run. So are we at a, do we need an elbow silencer? We could look at that, but we always want to use the straight silencer first to handle the cost, and we don't necessarily need to spend more money just to solve a simple problem. So same thing, RTU1, all the same data that we carried over, straight duct down, elbow over. We disabled the straight duct. We picked a silencer in here to get to NC 35. Pressure drop on, in particular on rooftop units, we want to be sensitive about the powered exhaust. It doesn't have always a lot of oomph. And if you have gravity relief, then you really can't afford a lot of pressure drop on this side. But we did just another, oh, I selected this at 40. Let's change that to 35. Oh, well, we were already there. See that? It selected us to 35 even though I changed that. So if I researched, it'll give me the same silencer. Again, it's telling us where our issue is. So we're not worried about whether we're off by 1 or 2 in the 63 or 8,000 hertz octave bands. We're only worried about our controlling bands. I'm sure taking its sweet time on this one. Yeah, so here's our different options. Different iterations, different pressure drops. If we were more concerned about trying to get that 0.03, we could switch it to this unit instead of the one that we had. If we're off by, we want to, you know, we're trying to limit the size of it because we're working on an offset, something like that. One thing I didn't bring up before is this inlet and outlet condition. Now, all of you have heard at some point or another me or another fan rep talk about system effect for fans. And when does that happen? When you have an elbow in front of the fan. If you don't have enough straight duct before the fan, too much straight duct after the fan. We have the same issues with silencers. So if you have a sharp elbow before or after the fan, I think it's worse on the discharge side. Let's say we had an elbow before it. We would have to reselect the unit, and we'll get a pressure drop that includes some losses for system effect. So instead of and I don't want to go through the whole selection process again. All it's going to do is take a correction factor on this. So I'm going to close that, but I think resources. If you look at this, this is similar to this button. This noise control engineering guide pops up. So look, straight duct. There is no issue. Notice that the geometry of this unit does not allow it to be flipped in the field. For every change, free air plenum with sharp inlet. correction factor of 1.1 to 1.3. Elbow in front of the silencer, 1.3. Fan discharge, 1.3. So we're trying to get to a certain pressure drop, but if we're too close to a fan, too close to a turn, whatever it turns out to be, just know the more turbulent the airflow is, the higher the pressure drop. So here we've got a silencer with turning vanes, kind of a minimal impact. Without vanes, I would debate that, but 1.1, so on and so forth. This is the outlet side. So if you change your area abruptly, that's a big difference. If you're going into a plenum, double it. Mitered elbow on the discharge, double it. Fan inlet, 1.2 or 1.4. So definitely stuff to be careful about, more on the discharge side. Okay, so we picked our silencer, we did our end reflection, we have satisfied the equation. Now let's blow this up and show where we started and where we ended. And there we go. I don't know why, for some reason, it didn't highlight this NC35 curve, but so we're not getting the output appearance that we want. Let's take an analysis report. So it's going to look at every one of these and give us a nice detailed output report, so we can turn it in for submittals, or we can look at it closely and admire our handiwork. So I just hit generate. Did I hit it? And there it goes. I don't want that. Sorry about that. Okay, so here's our analysis report. It's showing us every item we took along the way. Our original exhaust fan didn't meet the criteria. This is the one where we tried with a straight silencer, see how we fell short in these bands. Here's how we did with the elbow silencer. We satisfied NC30. Here's our rooftop supply unsilenced, how close we were. In just that little bit, we were all the way up in the NC45. And then we put our silencer on, and this 4K octave band was our controlling band. And here's our return path without NC50 and with NC34. And let's see. So with your salesperson at Airflow, they can put together a submittal for you. And that just takes a second. Because you have that acoustic report, but it doesn't tell you how big the silencer is, it doesn't tell you how it's built, it doesn't tell you the construction. So now we're giving, this is what the contractors use to configure his duct layout, put the silencer in, all that kind of stuff, and it'll be done in just a second. I promise it'll be done in just a second. All right, let me move that over. And many of you have seen noise control submittals from Airflow before. Here's our schedule. Straight silencer, 10 foot, elbow silencer, 10 foot, and 2 shorter rectangulars. That's what it looks like. Pretty simple drawing. If we were to put in our system effects, these values will change. It'll tell you that there's a system effect too. Small elbow silencer, high insertion losses. There's your pressure drop on the submittal. There's your media. There's what we're making it out of. Now, what's interesting, if you're not familiar that much with silencers, they build them in the little modules. They don't just build gigantic silencers. They take small modules. That's what all those little nomenclatures are. It has to do with the spacing of the baffles. So you don't make a 60 by 30 silencer, you make a bunch of little ones and you put them together. So on and so forth. This NVLAP certifies that Price's lab is up to the highest acoustic metrics. So they, Vibro, I think are the only two that do tests for all the different geometries. IAC used to be the granddaddy of the silencer business. They would take a 24 by 24 silencer, they would test it, and then they would assume that even if you change the width and the height, that all the insertion losses were the same. Well, that's not true. Think about it. If you have a 24 by 12 silencer, is it going to perform the same as a 24 by 24? Not at all. So Price tests all these different geometries, as does Vibro. I don't know that anybody else does it that way. But it's just one of those, like, hey, this is the way to go. All right, we have covered a lot of ground. Last thing I'd say is, I said, nope. What was that? Just one sec. Just gonna dig up one more thing here. I've called on a lot of you for flex duct, and it's kind of like, okay, who cares? It's flexible duct, right? Was that you laughing, Dave? It's true. Like, who cares? It's flex duct. So the sales guy came in, it must have been 7 years ago, and I'm looking at this data, I'm going, this is incredible. Why are we bothering with silencers? So a 6-foot section of 12-inch diameter. Here's our insertion losses. This is this is, now how does this work? Like, how can we get that much DIL? It's incredible. Well, we're cheating, which is like, cheating's good when cheating works. So this media inside here is acoustically transparent. All this stuff is intended to do is protect the fiberglass from getting into the airstream. It's the same material that you make a HEPA filter out of. So what we're allowing to do is allow the sound to break into the fiberglass, bounce off the vapor barrier, come through the fiberglass again, and then the lower frequency stuff actually busts through the vapor barrier. So absolutely we are cheating, but let's cheat smart. If you have a cloud ceiling, don't cheat, because it's not going to do you any good. You're going to have all that sound break around the ceiling. If you have a good ceiling and you have an acoustic issue, man, oh man, this is like free insurance. And it's more expensive than the really cheap stuff, but man, does it work. And it's 6-inch diameter, 17, 18, 10 decibels in the lower octave bands is so hard to come by. You go back to our acoustic analysis. This is a pretty intense silencer here to get to 15 dB in the first octave band. You can knock out this is a less expensive, less intensive silencer, but look at what we're doing. Same insertion losses without all that metal. So just an idea for you when you're trying to, it's hard, sometimes it's hard to get a silencer shoved into an existing duct location after the ceilings are up, but that flexible duct is a pretty powerful tool for saving someone's bacon. So with that, covered a lot of ground in about 50 minutes. Are there any questions, or should I be looking at this chat box?
Nothing in the chat box, Tom.
Nothing in the chat box. All right. Who's got a question? Or did everybody leave?
Do we stock that flex?
I think we do. Yeah, we do.
trick question, Tom.
That was, you're seeing if I'm on the ball.
I think we also stock the little 90-degree elbow holder thingies that keep your flex at a nice 90.
Yes, that's also true.
And if anybody doesn't believe the losses on that flexible duct, I mean, we can bring it in and show you guys, give you guys a little demonstration that when Tom does it and shows it to people, it's amazing how much it knocks down the noise.
Yeah. And if there aren't any questions, we really appreciate you coming in. I'm doing one more class, at least for now, on just how I look at fan selection software. It's a little bit differently than I can pick a fan. We can all pick a fan, but how we pick a fan is kind of what the subject at hand is. So I hope you guys at least look, silencers are cheap, flex is cheap. Keep yourselves out of trouble. Know when you're going to be needing one. Fixing acoustic problems after the fact is really, really tough. But this, we can do an analysis if we have sound power levels, just a ballparker in 5 or 10 minutes and decide whether or not, number one, you don't need it. Number two, we should throw something at it. Or number three, we should send it into price or airflow to just do an acoustic predictive and see how much trouble. By the way, it's free. Even if they come back and say, throw 10 feet of liner on your supply duct and you're good, like that's free. So we want to be the place you go to help solve your acoustic issues. Yeah, we want to sell you a bunch of silencers or have you specify silencers, but there's no rocket science here. It's really simple stuff. It's just sort of a tedious program. And with
I know
that,
we can't see any hands here, so I'll just say this. So I'm going to put this out there. If anybody had trouble downloading the software or would like to download the software or wants somebody to walk them through it, feel free to reach out to Tom, me, or Dave, and we can help you get that set up and walk you through any of the things that All-in-One can do. There's actually a lot of really interesting things in addition to this sound calculation thing. So I just wanted to put that out there while we got your ear.
all right, so I guess that's a wrap. Thanks everybody for coming. And if you feel like hanging on for a couple of minutes, just ask a question. That's fine too, but we'll stay here till 4:30.